Alright, let's move with the first question in chapter 7's revision kit, which is this. The following times taken to produce a batch of 100 units of product X have been noted. They've given the minutes. What is the median time? Now, first of all, we know in calculating means or median, we first have to identify whether the number of items is an odd number or an even number. Okay, so for that count the number of items given. So 3 this way and 1, 2, 3, 4, 5, 6. So totally 18 numbers. 18 is an even number. Even number means divisible by 2. Okay. So if it's an even number, if you are to find the median. Now what is the median? Median is the middle value of or middle item. Okay, middle item. Now since it's an even number, 18 numbers, we cannot actually find the middle item exactly. So what you should do, you should take the middle value of the arithmetic mean, which means first of all when finding medians, the first rule basically is to sort the numbers in or data in ascending order. Fine. So let's put it in ascending order, small to big. So we have 11 minutes and 3:17 minutes. 11, 17, 17. Fine. And then what else? 20. After that, 21 minutes. There are two 21s. And then 24, 27. There's 15 minutes as well. So arrange it. This is, you have to quickly arrange it. 15, 18, 20, 21, 23, 2:24 minutes, 1:27 minute and 29 minutes. Okay. Totally, let's see how many numbers. 40. We are missing some. So we got 11. Fine. So this is in ascending order. You go horizontal. Read it horizontally. Okay. Accordingly, what will be the middle value? So if you you can use this nth term formula where you get the middle value or the median value, which is by n plus 1 divided by 2, where the total number of items is n. Now total number of items is 18 as per the question. So 18 plus 1 divided by 2 is 19 divided by 2. Is equal to 9.5th value. The 9.5th value. Now what is the 9.5th value? Let's count. So this is the first value. Second, third, fourth, fifth, sixth, seventh, eighth, ninth. And 9.5th is between 9th and 10th value, isn't it? Therefore, what will be the middle value? 9.5th value. 21 plus the other 21 divided by 2. Alright. to find the middle value because there are two numbers. Basically, this we call the arithmetic mean, right? Addition of two numbers and dividing by 2 if your total number of data is an even number. Okay. Therefore, your answer will be 42 by 2, 21. Next question. Question 6. Okay. So here, the distribution of average weekly wages paid to direct labor at the factory of Parrot. So they've given the weekly average wage. If you see, it's a continuous data set because but it is not continuous as such. The reason is because they have not put the equal sign here. They have only put less than sign here, and then they've just same value they have taken, and it's always the less than sign. So they have not put any equal sign. So this is a discrete data. You call it discrete data where the data is not continuous. If it's continuous, you will be saying the word, if it's a continuous data set, you will use the word up to and including. Okay. So this will be like up to and including 61, up to and including 66, something like that. Alright, in your textbooks you all must have come across. So if it's up to and including, it's a continuous data set. But here they have given the sign and they have not given the equal marks, so it is a discrete data set. Now, the question is, using a standard interval size of 5, calculate the frequency density corresponding to the letter A, B, C, D. Frequency density is this, and they want us to find these letters value. Okay. So, first step is in a grouped frequency, we learned that identifying whether the class of the group is equal or not. Identify the group class or width is similar in all cases or not. So, let's see. The first width, basically, it is similar, isn't it? It is similar. Like it is 51 minus 61, the first width is 10. Second width, 61 minus 66. What's the answer? 5. Next one, 66 minus 71. 71 minus 66 is again 5. 71 to 76 is again 5. 76 to 81 again 5. 86 to 81 is 5. 91 to 86 is again 5. And 101 to 91 is 10. So this is the current class width. Okay, current class width. Are they same? Now our first step. So are they same? No, because everything is 5, that's fine. But this 2 is not the same. Therefore, we should use something called the adjustment factor. In the adjustment factor, what you do is, you get your, I would put it on the top. So for the adjustment factor, you get your standard width. Standard width is given in the question. They said use the standard width 5 rupees. Okay, so 5. Alright. Okay. So if it's the standard width is 5, the adjustment factor should be, we have to adjust this and this, right? So we get the adjustment factor standard width divided by current class width. This is what you should do when it comes to discrete data. And especially when the class, actually when the discrete or continuous, it doesn't matter, but the class, where the class differs, and mostly it relates to discrete data. Okay, so but for continuous data also you will use the same method, so don't worry, only thing is the change in the class width. So the adjustment factor you take for all, here it's 5 divided by 5, so it's always equal to 1. Okay, now get the frequency. I'll tell you what frequency density is at the end. First, let's get the frequencies in order. 13, 12, 16, 21, 25, 20, 14 and 9. Okay, so accordingly, what is the frequency density? Now, frequency density, you must not have heard of this word specifically in your textbook. But this frequency density means the height of the histogram bar. If you see the chapter 7 and look at the section for unequal class intervals, you will find the frequency density for which shows the height of a histogram bar. It is the height of the histogram bar. So in unequal class intervals, this is an unequal class interval because it's 5 at one place and 10 at another place. Then your frequency density therefore will be, so first of all you get your adjustment factor because it's unequal. Now you consider the frequency density, which is frequency multiplied by the adjustment factor. There you go. Everything gets multiplied by the adjustment factor. Accordingly, this is A, I guess, B, this is what they've asked. So A, B is next to 13 and 12, C is next to 16 and D is next to 9. 9 is the last one. So these are the answers. How you got it is by multiplying your frequency with the adjustment factor. Its adjustment factor will come to the scene only when there are unequal class intervals. Remember that. If the classes are equal, then you don't have to do this. Straight away, the height of the bar will be equal to the frequency because it's the same, but it isn't likewise for unequal class intervals. Alright. Next, let's move to question 30. Sorry, question 30. Okay, here they say the sales of color televisions on each of 40 days, every 40 days, for each day for a 40-day period. That's why the frequency here is 40 because the frequency represents the number of days. Okay. The sales is 0 to 3 sales we make for 8 days. 3 to 6 sales we do, 3 to 6 units we sell for 16 days. 6 to 9 units we sell for 12 days usually. And 9 to 12 units we sell for 4 days. That's how you read the frequency distribution. And the total of the days must be equal to 40 because they have checked the sales only for a 40-day period. Now they are asking they want us to answer whether the variables in the table are discrete or continuous. I told you if it's continuous, the equal sign must be there also in both sides. Also, mainly it's that it should include the word up to and including. This word up to and including. But it isn't like that. They have given this signs. If they give sign, it is always a discrete data. Okay, fine. And next we go for the arithmetic mean. So the arithmetic mean, why they say so is because this is a grouped frequency. You all must remember, in a grouped frequency, when we get the total value of the frequencies, we don't multiply by anything else other than the midpoint of the daily sales. This midpoint is of the daily sales always, or daily, whatever the range given here. Okay, so the midpoint, I'm going to start with the midpoint. So 0 to 3. So here it is only greater than 0. That means it's not equal to 0. So, but it's less than or equal to 3. So, my values in this range is 1, 2 and 3. Next one. It is only greater than 3. But it is less than or equal to 6. So, for 3 to 6 range, I will have 4, 5 and it's equal to 6. So I include 6 here. Then 6 to 9, same way. 6 to 9, they follow the same signs for both. So 9 to 12 is also the same way. Be sure of the sign given. So it's 7, 8, 9, 10, 11, 12. Right? Okay. So now what is the midpoint? This is the range. What's the midpoint? Of 1, 2 and 3? 2 is the middle value, isn't it? Because there are 3 numbers. So there should be a midpoint has an equal spread before it and after it. Okay? That's how you confirm. So 5, 8 and 11 will be your midpoints. But then what is the frequency? They've given 8, 16, 12, 4. 8, 16, 12, 4. Then what's the total frequency? The total frequency is 8 into 2 and so forth, and you get the total 236. So the mean is fx, which is this, divided by the total frequency f, which is 40 days. So mean will be sigma fx divided by sigma f, 5.9 units per day. Alright, so this is what you get as the answer for question 30. Next, let's move to question 16. Here, they say the common class width in a histogram is 20 rupees. One class has a non-standard class width and an actual frequency of 100. If the score plotted is 80, what is the width of the non-standard class? Okay. So that means they are saying the adjustment factor. Right. So they are saying common class width. That means the standard width. Okay. Standard width is 20. But there is one class. So we don't know what is the actual class width of that class. That is what we are going to find. We don't know. That's equal to x. But it has a frequency of 100. And the score, if plotted, is 80. That means, what are the meaning is that the What are they meaning is that if you look, let me show you that what we did previously on adjustment factor. But the score of 80 is they are referring to this frequency density. Okay, the frequency density. So it's basically the frequency density or height of the bar, which is 80. So how to get frequency density? Frequency density equals adjustment factor multiplied by the frequency. We know the frequency density is 80 and the adjustment factor we don't know, but we do know the frequency is, let's put the adjustment factor as y, frequency is 100. So what will be the adjustment factor? Is 0.8. Okay. So if the adjustment factor is 0.8, then what's the formula for adjustment factor? Isn't it linked to class width? It is linked to class width. It is standard class width divided by the current class width. The standard class is 20. Current class we don't know, but the division of that is equal to, we know it's 0.8. Therefore, X is, or the actual current class is equal to 20 divided by 0.8, which is 25. So the answer for this is D, 25. So remember, if they say if the score plotted, they are referring to the frequency density. And then if they are referring to frequency density and if you see some question relating to class width, then remember it's around these formulas. Remember the adjustment factor formula first. And then remember the outcome of the adjustment factor, which is the frequency density formula. If you are able to get this instantly as you look at the question, then it's easy for you to solve. Whenever you see questions relating to class width, remember the adjustment factor formula. Alright? Because that's where they would like to test you. So with that, we finish chapter 7 revision and let's move to chapter 8. Okay, now let's look at chapter 8 questions. Question number 1. Okay, a distribution where the mode has a lower value than the median and median is less than the mean is known as what? You know, in a distribution table, a graph, it's like a bell-shaped curve. In your textbook, they have clearly stated. In a positively, you can have a positive skewness or a normal distribution or a negative skewness. So these are the three possibilities. When the mode is less than the median and median is less than the mean, actually it's a positively skewed distribution. Positively skewed means it is more towards the left side, whereas negatively skewed means it's more towards the right side. So this is basically to let you have an understanding of reading the data, but it's basically more towards showing you the distribution. So basically you see, this is where your textbook mentions it. It is to read your, so skewness basically is the symmetry of a frequency distribution curve. How asymmetric is your frequency distribution curve? If it's symmetric, then it's a normal distribution. Okay. So, next let's move to question 4. So here it's an easy question. They are saying quality control of for independent processors reveals the length of certain parts in millimeters as follows. So the mean length for each process is given, and the deviation of the actual data from the mean is also given. Okay, so I told you standard deviation is the deviation from the actual data. So they are asking what is the process? The process with the largest relative variation measured by the coefficient of variation. Now here you must remember the coefficient of variation formula, which is standard deviation divided by the mean. So the standard deviation is 10, mean is 100. So this is for process W. The answer is 0.1. Right? For process X, it's 40, actually 5 by 40. Zero point 125. Okay. And process Y, same thing. Standard deviation is 8 and the mean is 80, which will give us 80 by 8 divided by 80, and then process Z is where standard deviation divided by 12 by 250 is basically 0.048. So if you convert this to percentage, now just tell now from the look of it, what is the highest coefficient? 12.5, and what process it belongs to? Process X. So the key learning is learning the formula, and therefore process X will be the answer, which is answer X only. Okay, because that has the highest, others are same as 10 and the one is below that. Okay, so learn this formula, memorize it. Alright. Next, let's go to question 80. Okay, looking at question, right. So this is basically the manager of a repairs depot is revealing the price charged to consumers for repairs. Analysis of the time required to carry out the repairs over a 1-month period is as follows. Repair time and the number of occasions. The repair time they've given in hours, number of occasions is the number of times they did the repair. And this is all the number of times they did within a month. They are asking to calculate the mean, and the 19th question is on the standard deviation. First step is to identify whether it's a continuous or discrete data. Whether it is a continuous or discrete data. Well, it's a continuous data. Why? Because it has the word less than. You see, it has the word less than, and it has the word this called, and in words, when they mention in words, that means it is a continuous data. Okay. So, continuous data, now having known it's continuous, now we should identify, so we've identified also that this is a grouped frequency, isn't it? Grouped frequencies, the mean or whatever is connected with the midpoint of the range. That's the rule. Okay, in grouped frequencies, that's the rule. So let's find the midpoint of the range. So the first one, now it's a continuous data. This is where continuous data plays a main role, like the word continuous. Why? Continuous means it's including all the figures. Now, less than 2 can be including minus, but there isn't minus hours, there can't be. But you know, you don't have a boundary. To create the boundary for the minus 2, this particular, the first line, see the class width of the next line. It's 2 to 4, 4 to 6, basically 2 to items. So therefore we can consider now 2 to 4 is 2, 3, 4. Likewise, less than 2 we will take 0, 1 and 2. Okay. So 0, 1 and 2, what will be the midpoint? 1, isn't it? Because that's the middle value. Right? So the next one. Now we are considering 2 here. Now see, because it is continuous, we are going to consider 2 in the next line as well. 2 and less than 4. Here we consider even 4. 2, 3 and 4. But if you are given a discrete data, if the data is not continuous but discrete, then in one place only you will consider this 2. Here you won't take 2. You will take 3, 4 and 5 or something. Okay. But in continuous data we consider everything. The last one, all the numbers we consider. So the midpoint is 3. This is the place where you have to be careful. Okay, 4, 5, 6 is 5. So I won't write anymore. I'll go on. 6, 7, 8, 9, 11, 13, 15 and 17. 11, 13, 15 and 17. Fine. And the number of occasions. So this is basically the midpoint. This is the range. This is the frequency. 3, 8, 21, 27. Sorry, 21, 37. 62, 38. 28 and 3. Now multiply the frequency to the midpoint to get fx. So x is the midpoint, frequency is f. So fx is the total to consider for the mean. So what is the total of these? (1,798). This total divided by the frequency will give us the mean, total of the frequency. So mean equals sigma fx, which is 1798 divided by sigma f, 8.99 hours is the mean. Then what's the standard deviation? For that, go use the standard deviation formula. What is it? It is so standard deviation formula is root of f x to the power 2. F x to the power 2. Okay, be careful. It's not the whole thing, but only x is squared. Right? Minus mean to the power 2. If you refer the book, you can clearly get the formula. So I'm writing it here. The root of the entire difference. So first, what is x squared? Now midpoint is x. Therefore, x to the power 2 is basically what? This midpoint multiplied by itself is squared, isn't it? That's what we learned. So 3 into 3 is 9. Into itself is the square. Likewise, take the total. And therefore, fx and then Multiply this by the frequency in order to get fx to the power squared. Right? So you multiply the frequency by this. Okay, so the total of it will be 18,080. Fine. This is fx squared. Then what's the mean? We know the mean is 8.99. But the mean square is what? Multiply the mean by itself. Okay. So this multiplied by itself is 80.8. Therefore, your standard deviation will be the root of 18,080 minus 80.82. What's the answer? 18,080 minus 80.282 is 79. The square root is 134.16. So sigma, so this standard deviation, then you divide it by, basically, actually you should divide sigma fx squared. I missed the formula. It should be divided by the frequency. Okay. Now therefore fx squared divided by the total frequency is 18,080 divided by 290.4. So this is basically the square root of 90.4 minus the mean square of 80.82. What is the answer? 90.4 minus 80.82. The root of it is 3.09. So 3.09 is your answer. Alright. So with that we finish a quick review of chapter 8 and let's move to chapter 9, probability.